So we are continuing our data analysis class, and today's topic will be EDA on TIPS dataset. This TIPS EDA stands for Exploratory Data Analysis. That means we kind of explore things that are given in the data with the help of whatever analysis we'll do. We'll try to draw some conclusions. The data set that we are using today is TIPS data set. In TIPS data set, you can see we have these 7 variables. Row is given, but it can be ignored. We have total bill, gender, smoker, day, time, size, and tip. Okay. This data set means that a waiter or a restaurant owner collected the data of these probably 200 people, 240 people maybe. So he collected data of these 240 people where whenever someone gave a tip of certain amount, he noted down other variables related to that tip. Okay. For example, in this case, total bill was 24.59. The person who gave tip was a female, non-smoker. That person came to restaurant on Sunday. Time was dinner. Size was 4. Size means how many people were there. Okay. This doesn't mean that there were 4 females and all of them were non-smokers. This data means that the person who gave tip was female and non-smoker. We don't have information about rest of the 3 people, whether they are male smoker or not, but it's related to the person, right? And usually what happens in a restaurant is there are 2 areas, right? Non-smoking zone and smoking zone kind of areas are there. So we can say that if this person is non-smoker or sitting in non-smoker zone, that also means that all of them were non-smokers. But we can, in case of smokers, we cannot say all of them were smokers. So no such information is given actually. So we'll consider this variable as just a discrete variable with quantity of people, like how many people ate that time. And this is tips. Such type of problems are part of such type of problems are part of supervised learning. A supervised data set is data set where we have sample input and output given. Okay. In this case, all these variables, all these selected variables are our inputs or features, and this variable is output or target. Okay. That means that this variable kind of depends upon value of these variables. Okay. So there will be some kind of equation to calculate the amount of tip if other variables had this particular value. For example, if bill was $26, male was giving the tip, non-smoker, on Sunday dinner, size was 4, so an ideal amount of tip would have been 3.12. Okay, so this is a very simple data set which explains how 2 numbers are associated with each other, like how 2 numbers are related, but these 2 numbers are also affected by other variables. The relationship between these 2 numbers is also affected by the value of these other variables. So when we try to explore the data, a very simple thing is to analyze if it is a number, total bill is a number. So we'll analyze if we increase or decrease the total bill, does that increase or decrease has anything or has any significant, uh, increase or decrease on the tip, right? This we'll analyze this. What type of graph we will draw and how we will draw, we'll just see in a bit. Second, when there are these nominal variables like nominal qualitative data, which Tableau calls as dimensions. So when we are trying to measure a dimension with a measure, so there are graphs like pie chart and bar chart. Okay, that makes sense. Okay, same goes to smoker, same goes to day, same goes to time. When we are analyzing a measure with dimensions, we can take sum as the aggregate function, and we can also take average as the aggregate function. So we will try to analyze what is the average amount of tip given by female, average amount of tip given by male, right? Total amount of tip given by female, total amount of tip given by male. So that way we will be able to get a lot of information, whether this information just tells us that if it is a female or male, does that make any difference in the output, right? So if it makes a difference, then we will consider this variable as an important variable. Otherwise, we can ignore this variable, right? So we'll simply go to our sheet, and the first graph that we will draw is if we increase total bill and or decrease total bill, will it cause any effect on tip? Now, in order to visualize or in order to show relationship between two measures, this is a very important thing. In order to show relationship between two measures, what you have to keep in mind is Tableau by default, you know, does aggregate measures. Okay, you can see aggregate measures is checked here. Okay, what does that mean? This means that when you will drop a measure here, we are selecting total bill. Okay, but when you will just select it, you can see it is actually sum of total bill which is being plotted here, right? Sum of total bill. This is an aggregate value, aggregate function sum, and we can change this aggregate function to average, we can change it to median or minimum or maximum, whatever, right? So by default it is sum. So by default we have not done any kind of setting or anything. This is just the default nature of Tableau, that when you will drag a measure, it will make it sum. Okay, if you don't need sum, then you can probably change it. So okay, we want to see, effect of total bill on tip, because that is the output variable that we have. So we can drag tip here, and similarly it will show sum of tip. So when we drag two measures, the default graph is a scatter plot. Okay, and you are seeing just one scatter point here. It is because because now it's just a point on the graph, right? Total bill is 4828 and tip is 731.6. So on x-axis it is 4828, on y-axis it is 731.6, and you know that when we are for a point, there are two coordinates x comma y. So this is x comma y. But with this we cannot tell whether by increasing total bill, whether tip goes up or tip goes down, right? So in such cases, what you have to do, just go to analysis and turn off aggregate measure. And when you will turn off aggregate measure, Now you don't see sum or average or anything anymore. Can you see it? So let's see what is count. So we will just simply drag count. So this is 244 values. Okay. So now you can see 244 dots here. Okay. And every dot represent a data point. Like this is one dot, this is second dot, this is third dot, this is four, and so on. Okay. So now all the dots are plotted on the graph. And now if I ask you a question, if we increase the total bill, will the tip increase or not? What is your answer? What do you think? So answer will be, obviously, if total bill is increasing, tip is also increasing. We can see that. But that increase is not linear. Okay.
Yeah, it's not linear.
Yeah. So answer will be, yeah, there is increase, but not perfectly linear. Yes, it is linear increase, but not perfectly linear. Otherwise, it would have been in a perfect line, right? A straight line. So these points are scattered, right? Because, and that's why I said, because there are so many other variables, and there is no such rule, right? There is no such rule that if your total bill is, you can see for total bill amount of $50, around $50, someone has given $5 tip, someone has given $6 tip, someone has given $9 tip, and someone has given $10 tip. Okay. Same goes to every value of total bill. So it depends upon quality of food, how how the waiter behaves, many such things that are not provided here. But what they have provided here is this information. Okay. Now once you have a scatter plot, then what you can do is you can use the dimensions in these marks. Okay. Right now we haven't used these marks. We have just used total bill and tip. We have created it all, by default it created the scatter plot. You can choose other type of graphs also, but I will explain about these graphs later, like what this means. Here we have total bill and tip, and suppose you want to analyze whether male, like where are males here, like where are males and females located here in this graph, right? So you can drag gender into color. Now here orange color represents male and blue color represents female. Okay. So you can see that all those tips which are of higher amount, like that we can see, all the tip and bill that are of higher amount, higher than the average, are by are paid by male, and all those tips in this region mostly are female. We can also calculate, or we can also see, like what is the ratio of male versus female, right? What is the ratio of tip, what is the ratio of bill givers, bill payers, or whoever has paid the bill. So out of 244, what we can do here for this type of analysis, you can either use text graph or pie chart or bar chart. Okay. So we have added our dimension here, and we can add the count measure here. Okay. So you can see that out of 244, 157 were female and 87, oh sorry, 157 were male and 87 were female. Okay. You can change it to text, you can change it to pie, whatever you want to do, you can do here. In pie, if you want to add more details to your graph, you can simply drag label here, okay, which shows ratio here. Now we will keep it like this. So obviously there are more orange points, right, which we can conclude from here also. There are more orange points, but it also tells us that actually male and female gave tips in different fashion. So the main conclusion or main uh, kind of analysis that I can draw from this is, yes, this variable called sex is kind of a deciding factor, right? It is somehow affecting the amount of tip. Do you agree or not?
Yeah, it is.
Right? So,
हाँ, साफ
th
साफ दिख रहा है,
yeah,
मेल की टेंडेंसी ज्यादा है टिप में.
exactly. Yeah. So, this is what, if suppose we did not see any difference, right? Or we do not see any significant change. So, in that case, obviously, there is something called machine learning that we do after data analysis. So, in machine learning, when you are creating models, right? While creating your models, do you want to consider this variable or not? So that is something that will be discussed later. But as an exploratory analysis also, if you are trying to suppose this is sales, okay, let's say the tip here is sales, okay, and total bill is something, some kind of numerical input in a company, and these other variables are other factors, right? Like we did the sample superstore dataset. In sample superstore dataset, there was profit, there was sales, there was quantity, there were so many other variables. Okay, so what is affecting sales? Like if we want to increase sales, what do we have to do, right? Which is our go-to audience to get more sales? In the similar way, if we want to maximize the total bill or maximize the tip here in this case, if we want to maximize the tip, what should we do, right? So bring more male customers into restaurants, so they will give you tip. So it is just
Yeah.
a simple thing. Now this is one variable, right? So uh, why did we plot this graph, or why are we are doing this exercise? To understand that if we have to compare or relate two numerical variables, numerical continuous variables, what is the best way to do it? Okay, this is the best way to do it. Okay, you can draw a chart, because if you will draw a line, I'm showing you will not be able to understand anything. Okay, if you draw a circle also, circle and scatter is one and the same thing. It is actually giving a better indication, right? And in case of circle, what you can do is you can increase the size. Okay, by increasing the size also, it will give you a good indication. Okay, like what is happening, and you can go to color and edit color. You can use any color you want, right? It you already know that you can, while applying color, you can use borders and different type of formatting related settings you can do, and opacity you can uh, consider.
सर
So
बेसिकली स्कैटर प्लॉट का अंडरस्टैंडिंग ये है कि ये दो क्वांटिटेटिव मेथड्स को कंपेयर करने के लिए यूज होता है.
exact, though numbers, there are two numbers, and one of them is not date, right? If one of them is date, for example, then we'll use line graph, because date, right, date is increasing, date is always independent, it increases. What is the, as we did in case of previous classes, right? Like with with order date or with years going by, what is the total sales, what is the total profit, and again how you are taking the date is also very important. If you are taking just the summarization, for example, if you are just taking years, right, then bar graph we can use bar graphs also to understand. But if you are taking date as a measure, right, if you are taking date as a continuous measure, then you can do that. So in this case, you can draw this. Now there are other cases like day is here. Okay. Again, day is also a categorical variable. We have four values here, four distinct values: Sunday, Friday, Saturday, Thursday. And again, as I said, there are, you can use bar graph, you can use pie chart. I will prefer bar graph for this, and we are checking tip. So here you can see, okay. And if you have to compare it with another important variable which is total bill, what you can do is you can drag the same thing, okay. So when you will drag the same thing on the same axis, because again both have units in dollar, right? So it will give you a comparison also, like when total bill is this much, if is this much in case of Sunday. In case of Saturday, you can see uh, total bill actually was more, but that, date at which total bill was more, tip was not, or tip did not increase with that same rate. Right? So you can draw a lot of conclusions from here, and as you can see, you can select, although it is side by side bar, but when you will select from show me, it will also add a color, and it will add this filter, right? So you can select only one value from here. This is kind of a filter, an interactive filter. If you don't select anything, it works as a legend. It is informing you that blue is tip and orange is total. So important point. On Friday, you can see, as we can see from here, right, that tip is kind of proportional to bill. When total bill increases, it is directly proportional. When total bill increases, tip also increases by some factor. So we can see that here also. Like on Friday, total bill is less, so tip is also less. On Sunday, again, as per amount of total bill we have received. So this graph is telling you few things. And similarly, you can plot other graphs. Same thing you can do with gender, but with gender, what we are going to do, obviously calculating sum will not make sense, because we already know that there are only 87 females. Okay, so sum will always be higher in case of male. But the main point to analyze here would be, if the average will average tip, what is the average tip, right? Maybe on an average female gave more tip. Okay, so average does not depend upon sum, like average does not
Yes,
depend
sir.
upon this value. So what we can do here is how to calculate average. So we can simply drag it here, and instead of sum we can use average. So in case of average, you can see again, this also concludes our simple point that on an average the tip given by male customers was more than female customer, irrespective of how many male and female were there. Obviously some will be higher, right? And if you want to show that average value, so you can copy this value and show it on label. Okay, so you can see that number. It's your choice how you want to display it, but this is giving you an information, that a very important information, that average amount of tip is more in case of male and female. We will also see total bill. So when you are comparing with total bill, okay, I want to compare with, I will add one layer here, yeah. So what confusion it is giving us is because we have only selected average tip here. So if we should remove this, this will give us an idea. So this is sum of total bill. We will not select sum of total bill. We will also say average. So on an average, in case of male, total bill was 20 and average tip amount was 3. In case of female, the average total bill is also less and so is the tip. Okay. So this is our exploratory analysis, and now smoker and time. So what type of graphs should we plot here? Again, for smoker it will not cause any difference here. So for a smoker we will draw the same thing. Like again, in case of a smoker, first we have to calculate count. Okay. So here also you can see non-smokers are more. Okay. So it will be better to have the average value rather than total value. Obviously total value will be more. So what we will do is drag smoker here, and what we want to analyze, later you can rename them, right? I'm not renaming them, I'm just drawing them, so you can do the renaming. So it is a smoker versus average tip, like whether the smokers gave more tip on an average or not. It is very neck to neck, but still average tip by smoker is more than average tip by non-smokers. So it looks like people sitting in the smoker area are giving more tip, but a very small margin. You can see 0.99, 0.0.
Small fractional points से ज़्यादा है बस.
Yeah. So it is not a very deciding factor that we should increase the size of the non-smoking area, right? Or we should decrease the size of non-smoking area based on total bill and total tip. And we can do the same thing for total bill, right? So we can drag average total bill here. In case of average total bill, we do see a difference, 20 and 19.1. Okay. Now here is something I want to include here. Suppose you are a restaurant owner. Okay. Although this is a very small data set. Okay. But suppose you have data of restaurants within your locality. Okay. You have data of thousands of such uh, objects, thousands of such incidents where a customer came to eat something, and in your locality, if you are seeing a very significant difference between count of people who are smokers, total bill, average bill, okay, so as a restaurant owner, it will be a very deciding factor for you that whether you should increase the size of non-smoker area or not, right?
Yes.
So if you are, because if person is smoker, he comes to the restaurant and non-smoker area is small, so he or she will see that it is already full. They will go to some other restaurant, right? And so that's how data kind of affects your decision. Although this is a very basic example we are giving, there will be a lot more analysis than just looking at this, but these small little factors kind of affect your decision, right? And that's why we call it data driven decision making. So, and that can actually increase the performance of your business, right? So that is, and don't consider these variables as just for restaurant. This can be any number, and there can be any number of, so just consider them as measures and dimensions. So in any business there will be numbers that indicate profit, indicate sales, they indicate any type of progress, numbers, and then there will be dimensions that that will help you in analyzing which dimensions are more significant than others, right? So that's what we do in this type of analysis, and that's why using something like Tableau is anyone can easily do this, right? So
Correct.
that's why it is very important. And now finally time, dinner and lunch, and same thing in time also. First calculate count, which you will see that more people ate in dinner time than lunch, so it's okay. And now again we'll do average. So time versus average total bill, average total day. So again very repetitive work, but again because there are so many variables given, we have to analyze them one by one, right? So this is also giving us an indication that average tip given an average bill in case of dinner is also more than lunch. It's not just total bill is more than lunch, it is also the average in dinner is more than lunch. So what will this or how will this affect some kind of business decision? Now, suppose we have a staff of 20 people, let's say, okay, and we analyze that the number of people that come for lunch is less than number of people that come for dinner, okay. So we can ask, or and obviously in restaurants there are shifts, right? So we should have more number of people addressing the customers in dinner time, right? We should have more staff in dinner time so that everyone is well fed, right?
Correct.
So we can reduce number of people in the lunch time. We can say, okay, we have 20 people, 16 will uh, at lunch time we will have only 16 people, but at dinner time we will have the full strength, okay. And then there are a lot of other factors that are not included here because this is probably data of 2 or 3 days. But suppose there is a holiday season also. Suppose this is we collect data of the entire year, and not just entire year, we collect data of 10 years, right? So you will
Okay.
see what are the peak times, right? What are the peak times when number of customers grows significantly. So in those cases you will arrange extra staff, right? But you will not keep that extra staff always because that will be underutilized, right? So
Yes.
so again that also depends upon analyzing the data. If you think closely, without even analyzing the data, these type of decisions are made by people, right? But when you are running something more, if you want to scale something, if you want to manage or organize something more professionally, then obviously data analysis will help you a lot, okay. And finally we have size here, right? Now size is a number first of all, okay. And how size affects total bill. So
Scattered plot.
yeah, we will draw scatter plot, okay. But here, since it's a discrete value, right? So you
Yes.
and you can see that in the graph also. Here you see something continuous, right?
Yes.
Here you'll see something discrete. That's the difference between continuous and discrete variable. Because in discrete there is no 1 point person, right? A person can either be one, the count of person can either be one or two. There cannot be 1.5%. If 1.5% came to eat, then it will be a weird situation. Like where is the
Yeah.
other half of it? So in such cases, instead of creating a scatter plot, it will be better to have a bar plot, isn't it?
Correct.
Right? So it is not always this case that if two measures are there, we will plot a scatter plot. It's also what type of measures are there, right? If one of them is this and other is total bill, if one of them is discrete and other is continuous, then we can draw this type of line. Just keep it. So now what is this telling us? The sum of total bill or the amount of total bill. You can see the numbers, right? The number of people who came to eat. So couples are there, right? We can say most of them were couples, right? And you have seen tables in restaurants, right? When you see tables in restaurant, there are tables with 4 people, 5 people. So you must have seen in restaurants that there are tables with 4 chairs, right? Tables with 5 chairs, 6 chairs, 7 chairs, and there are small tables with 2 chairs, right, for couples. So
Yes.
this can also affect your decision of how, how many couple tables you should have, how many, 3 tables, like 3 people table, 4 people table. You understand what I'm saying, right? So if suppose all of these bars were equal, in that case our decision would have been different. But what we can see, out of 240 people, okay, let's get the count also. Now how can we get the count of this? So if we drag size here, okay, okay, we got size and we got count. So this way we get the count, but it is giving 111. Okay. So these type of variables like size, which is a discrete value, what we can do is we can duplicate it. Okay. Let's see what I'm doing, and convert it to dimension. Do you get my point? So we have kept the numerical size, but in a way this is also a label, right? We can call single, couple, triplet, quadlet, whatever we call it, right? So here what we'll do, we'll drag this dimension, okay, whatever is showing us, and we will drag tip or some. Just give me a minute. Yeah, now I have to turn it on. Yeah. So what it is showing us, size and count. Okay. So count of total number of people is 156 who came as a couple. Okay. Out of 244, which is a significant factor for deciding that we should have more couple chairs, right? So now do you get this point? So this way we do the exploratory analysis, and now you can create your dashboard, right? First let's delete this. You can you can adjust the size as per your screen's width and height, and now you can simply create graphs. Okay, and we will drag sheet 2. When I am dragging the sheet 2, it is giving me these 3 places: on top, left side, right side, on bottom. I will drag here, right? It's a very small graph. We'll drag something below it. Okay, this, and we can use it to adjust the height. Similarly, we can drag this here. We can drag something here. Obviously, we have to make it more meaningful, but this is how we actually analyze things. Okay, and now with the help of this information or whatever we have analyzed today, you have to go ahead and create some kind of dashboard. Okay, and just let us know.